Hi. Okay. Hi, everyone. Continuing the series of putting the videos that we do in the live sessions for the JMED Math Clinic and showing those videos, making them into a package so that students who miss those lessons can, get a chance to see these videos again. So today's video is going to be one from the archives. It's a lesson that was done maybe a few weeks back. But increasingly, we see students asking, when can I see that lesson, or can you teach this topic? So this is just an attempt at ensuring that we bring that consistency, bring some clarity, and ensuring that students can make that movement forward. So we're going to get going on the video, but just remember the JMED Math Clinic is free to anyone who wants to join these clinics, and really the focus is on just helping students with their mathematics. So if you know anyone who's having challenges with CSEC mathematics or even GCSE mathematics, just point them to the Math Clinic. It's held every Sunday at 11 a.m. And we just ensure that we provide some knowledge and share some of our passion with students. So let's get going. Today's lesson, we're going to be talking today about quadratic expressions and how to factorize them. And I always try to share some of my thinking in the problems, not just necessarily just to say this is how you do it, but also to kind of give you a way in which I think about the problem, and also share some from my experience, the kind of things that students would have problems with, and try to ensure that the explanations are good enough for you to use them and be better at your math. So today we're going to look at how to factorize expressions, and hopefully as we go through that, you'll become a little bit stronger. And please feel free to ask questions in the comments, or even ask for different videos, and we'll put those together. So quadratic expression, is a polynomial with a degree of 2. Now, what does that mean? And those kind of definitions, it's important that you understand the basic kind of definition that's in textbooks and so on, because, it's not good to just learn a kind of simple definition. You need to understand the terms and begin to use those terms. So something like a polynomial is going to be useful as you develop your mathematics. And degree, and what degree? So I'll explain what that means. A quadratic expression is an algebraic expression where the highest power of the unknown is the squared power. So the highest power, is 2. And so once we look at an equation that has like x squared, and we talk about the degree, we're talking about like squares highest power. So for example, if you look at this example, you'll see that we have x squared, we have 7x plus 7, x squared minus 7x plus 7. The highest power that's in use in this one is x squared. So that gives you an idea that this is quadratic. Even though there's an x here, the fact that the highest power of x is quadratic. I'm going to put some other expressions here, and perhaps you'll see exactly what I mean. These are all quadratic expressions, despite what you may notice, even though it says minus 2x squared, even though it doesn't have 3 terms, whether it's minus x squared here, whatever the format, these are all quadratic expressions because the highest power of the variable is 2, has a degree of 2. And it's a polynomial because it has unknowns like this, just algebraic terms like this, 4x, 5x, 7x, stuff like that. So to factorize the expression. So one of the skills that you need to develop as a student, and this is maybe factorization 3 before, we have looked at basic factorization. We have looked at factorizing by grouping. And then now we're here at factorizing quadratic expressions. So if you haven't seen those or been in part of those lessons, then it's important that you understand that you need to see how to factorize both types of factorization before you can fully understand the steps that I'll take when I go through factorizing in this, because I'm not going to go straight to the answer. I'm actually going to do factorization by grouping as a way of getting us to the quadratic expression. So factorize. So here's our thing. The key thing here is to understand how quadratic expressions are set up when they're in this form, or equations for that matter. So the last term has a connection to the middle term if the expression can be factorized. If the expression can be factorized, there's a connection between these and these all the time. And if you understand that relationship and maintain that relationship between the two, then you can work backwards or forwards, you know. So we're going to get into the basic thing is that we need to find pairs of numbers that multiply to get 15. So we can list all the pairs that we come up with: 5 by 3, 15 by 1, negative numbers as well, negative 5 by negative 3, and negative 15 times 1. Now, you might say, oh, I could go on forever, but no. The numbers that we use have to be integers. So that's why I have this another mathematical term. And these are whole numbers that include 0 and the negative numbers. So, but these are whole numbers. So this is not a search that can go on forever. There's a point where there's no more, there are no more pairs of factors which are integers that exist. And in this case, these are the 4. Now, some numbers could have a lot. And so that's why we need to develop, you know, good techniques so that we can quickly get to those numbers. But in reality, the numbers that we're using will be like this. Okay, so this is 15. Now we need to find the pair of numbers that if we add them together, we get the middle term, which in this case is 8. So we're looking for the pair that when we add the numbers together, we get 8. Which of the pairs add up to 8? Okay. Once we identify the pair, we're going to split the x term using those numbers. So notice that we have come up with the conclusion that it is 5 and 3. Now 5 plus 3 is 8. So we're at liberty to split that 8 into this format: x squared plus 3x plus 5x plus 15. So this is a basic skill. First step, we look at the last number. We try to find pairs of integers that multiply to get to that number. That can be, in some cases, 4 or 6 numbers, 6 pairs. From those pairs, look for the pair that adds to the b or to the middle term, the coefficient of x, 8. In this case, we're looking for 8. So 5 and 3 are the only pairs that work. So then we rewrite the expression x squared plus 3x plus 5x plus 15. This is a technique that you need to master the first stage of this. So remember that we were working on x squared plus 8x plus 15, and we have rewritten this as x squared plus 5x plus 3x plus 15. If you look closely, we haven't changed the value of the expression because this is the same as this. It's not different, it's the same thing. We have just rewritten it in a specific form because we need to factorize it. If we do not write it in this form, it will not be factorized. It will just go to a dead end. So we need to make sure that when we factorize, we choose the format that leads to a factorized form. But if we had tried 15 and 1, it wouldn't have been factorized in the end. It would just go to a dead end. So that's why we have to choose a pair that leads us to the factorization form. So we get into the thinking zone. We look closely. We don't see any common factors, neither in the letters or in the numbers. So we continue. We need to group the pairs that have a common factor. So we're going to group x squared with 5x and 3x with 15. Okay? And notice I've just put them in bracket and I've just slotted up an addition sign between them. So I've not done anything except just put brackets around the terms. Then I'm going to factorize each pair separately. So if I factorize each pair separately, for this one, we can take x out. If this is new for you, you need to go and see the earlier videos on how to factorize, basic factorization. But essentially, we're looking to see what's common. And when we factorize, if we multiply the bracket again, we should end up with the same outcome, meaning x times x should give us x squared, and x times 5 would give us 5x. Likewise, here we factorize, we can take 3 because 3 is a common factor of 15 and 3. So we take that out and that leaves us with x, leaves us with this expression. Now, we need to check that the brackets are the same. And in this case, they are. So if the brackets are the same, what we will start to see, we just rewrite this by putting the outside of the bracket, x plus 3 in one bracket, and just write the repeated bracket, x plus 3. All right? So the order wouldn't matter. If you had put x plus 5 and then put x plus 3 after, it wouldn't matter. But I tend to just go x plus 3, one bracket, and then rewrite x plus 5. Effectively, what we're doing is factorizing again to get to the final answer, because this is a common factor now. X plus 5 is a common factor, so we can rewrite that common factor and then divide through to get what's less. But pictorially, quite easily, if you just look at it, you'll see visually that x plus 3 goes in one bracket and x plus 5 goes in one bracket. And we don't have to repeat that x plus 5 because we're just factorizing. And so the final answer is x plus 3 and x plus 5. Let's continue. Here we have x squared plus 9x plus 20. So for 20, we need to find two numbers that multiply to give us 20, yeah? And so effectively, we need to look at the 20 and say which numbers need to multiply to give you 20, but when you add them, you get 9. So we're gonna have a look. We find that to be 20 is 4 times 5, and 5 plus 4 is 9. So that is a pair of numbers that work. So we rewrite the expression as x squared plus 5x plus 4x plus 20. Remember, there are many ways you can write it, but if you do not choose this combination, it will not be factorized. It will just go to a dead end. So you need to make sure that you've chosen the right one. And how do you know the right one, the right pairs? Numbers that multiply to be 20, but when they added, you get positive 9. No common factors are present. The x is not in all the terms, and there is no single number except 1 that divides into all of these. Group pairs that have common factors. So we are going to just bracket them up. In some cases, you don't have to move them, but sometimes you might have to rearrange the order that you've been given in an exam. But for quadratics, it will be okay if you just keep it. Factorize each pair separately. Talked about this already. So we can take x out, we can take 4 out from this one, and we'll end up here. We check that the brackets are the same, and they are, so we can factorize. So we end up with x plus 4 and x plus 5. And again, that x plus 4 is these two together. Whatever the sign is, you'll take that, and x plus 5. And then you factorize, you just rewrite that as your final factorized form. X squared plus 2x minus 35, another example. And if you're okay with these, you can start working through them and then check to see that your answer is correct. So what you can do is pause the video and see if you're okay. The first thing that you need to think about is what two numbers multiply to give us negative 35, but if we add them, we get a positive 2. Now, the fact that it's negative 35, you should be thinking that it has to be one number is positive and one number is negative. And if I'm going to get a positive 2 when I add them together, the bigger number must be the positive one, right? So that's the kind of way that you think about it. Now, the two numbers we're looking for is positive 7 and negative 5, because 7 times 5 is 35. So next 7 times negative 5 is negative 35. And minus 5 plus 7 is a positive 2. So there's a little bit of thinking here. So we rewrite the expression, x squared minus 5x plus 7x minus 35. No common factors are present. We've done that check. We group the pairs that have a common factor. Yeah. And then we factorize each pair separately. As I said, you can pause and then have a go at each step to see if you're on the right track. And then the final answer is x plus 7, x minus 5. And so we end up with final piece here, factorize. As I said, if you keep practicing, you will be fine. The methodology doesn't change very much. It's the same approach to it, even if it's negative. You just need to make sure that you get the right thing. Now, remember, the thinking zone is my thinking process. You really don't need to write this when working. When you're working on the problem, this is all your teacher expects to see, or your examiner, you know. But here is my thinking, letting you see what's going on in my brain. Why am I taking each step? So that you can understand what goes on in the brain of someone who's doing math. But you don't have to write these. You just need to know these steps. X squared minus x minus 42. Again, we want to find two numbers that when we multiply them, we get negative 42. And when we add them, we get minus 1. Very important. We need to get negative 1 when it's finished. Because even though we don't see a number here, hey, don't assume it's 0. It's negative 1. So the two numbers, as I said, you can pause the video, give yourself some chance to think about this. And if you do think you'll find these numbers by finding pairs that multiply to give you 42. In this case, it's going to be -7 times 6. And if you add -7 plus 6, you'll get -1. So we have found the pair that works. Once we split, the process is fairly straightforward, grouping the common ones, factorizing them separately, checking that the brackets are the exact same, and then combine to form the factorized expression. All right, so the methodology here is very straightforward. If you look at the thinking, I'm not creating new thinking, same steps each time. So one of the questions that people may ask is there a pattern? I always believe that once you've practiced with something in math, you should really start looking to see if there are patterns, because we really want to develop the ability to recognize relationships between numbers and actions you take in order to be able to become better at maths. You know, those patterns are important. So if you look at x squared plus 8x plus 15, the numbers that we use are 3 and 5, and our factorized expression is x plus 3, x plus 5. Now you can start seeing that there is clearly some pattern existing here. Let's do another one, and maybe you'll see a clearer pattern. We did x squared plus 9x plus 20, and the numbers were 4 and 5. What was the factorized expression? X plus 4, x plus 5. Let's look at another one that we did. X squared minus 2x minus 35. The numbers were -7 and 5. X minus 7, x plus 5. X squared minus x minus 42, -7 and 6. X minus 7, x plus 6. So there's clearly a pattern. What would be used? 2 and 10, and x plus 2, x plus 10. So we don't really have to, once we understand quadratic factorizations, once we identify those numbers, we can go straight to the expression, okay? And write that. That's not a problem. That's something you need to know, because it will speed your work up when you move on in math, all right? So if you want to continue to test that pattern, here we are. Here are some examples. You can pause each one, come up with your response, and then check the answer. Pause it for a bit, then check the answer, pause, check the answer. All right? So those patterns really work when the coefficient of x squared is 1. So if the coefficient of x squared is not 1, then you need to think deeply about how you do the next one. I'm going to take you through that process now. So when the coefficient of x squared isn't 1, the process is slightly different. There's an additional step. So we need to get into the thinking zone. What we need to do here is multiply 2 times -5 to give us -10. And you know that number that we had at the end that we were working with? We use that number as the guiding light, okay? So it's 2 times -5 to give us -10. And then we do the work with -10, all right? So we use -10, we need 2 numbers to multiply to give us -10. So -10 times 1 works. And if you add -10 with 1, you get -9. We go in, we split like normal. So the procedure is really the same, except that original step. Group pairs that have common factors, factor completely each bracket. So 2x will come out rather than just x, because 2 goes into 10. That gives you 5. And then we take 1 out. And I'll clear this 1 out very, very clearly, so we know that 1 has been taken out. 1 is, in this case, a factor. And then we simplify. We just rewrite this as 2x plus 1. Remember, we get this 2x. Remember this 1. Put together, and we repeat the bracket. And that's our answer. So the only new step here is to remember to multiply. Effectively, in the others, we were multiplying by 1, but we didn't do it. But we were multiplying by 1. So the step is the same. We always multiply the coefficient of x squared times the last one to get the number that we actually use. Another example. So in this case, we're going to do what? We're going to first multiply 3 by 8 to get our starting number. And then we say we have 24. What numbers, when you multiply them, you need what numbers that multiply to give you 24. If you add them, you get -14. And if you look closely, you'll get -12 and -2. -2 times -12 is 24, and -2 plus -12 is -14. So we split using those numbers, these ones, we split, and then we continue the work as normal. Group, factor out 3x and minus 2. Yeah, notice when I have a negative sign here, I don't worry about it. I put it inside the bracket, put a plus still, and then I take that negative 2 out, which means all signs inside will change. So when I take negative 2 here, this becomes positive x. When I take negative 2 from the 8, we get negative 4 when you divide, because that's how it works. And then if we multiply out, we'll see. Brackets are the same, so we know we're on the right track, and we just combine to get our final answer. Another example, we do 4 times 9 to get 36. And we know that the numbers that we're using in this case must add up to minus 12, but also multiply to give us positive 36. In this case, it's negative 6 and negative 6. We split, we organize, we start to factorize. So here we're taking out 2x because 2 goes into 4 and 6 and x. And we're taking out 3 because 3 goes into 6 and 9. Again, we have the minus 6 inside. Notice I've put that inside the bracket. Then I've taken the minus 3 out, which changes the sign here. And then we're okay. Just put a plus between. Don't worry about the minuses. But you need to put the plus. You can't just put minus. It will be wrong. Yeah? Check that brackets are the same. And then we get the same thing in each bracket, which actually means that this expression is what we call a perfect square, because this is really 2x minus 3 squared. And that's just a special outcome. It's nothing fantastic, but it's just what it is. All right, so we've had a look at factorizing expressions. I hope that that video gives you some form of an understanding about the processes that you should take when you're factorizing. Again, these are just to help students who have missed some of the lessons so they understand how we factorize. I'm going to see if I can find the videos on earlier factorization so that you can use those as well to help you study. But if you watch those videos, you'll become a little bit clearer about the thinking processes as well as the methodology behind it. Perhaps the best thing to do is try and find the 3 videos, one on factorization basic, then factorization by grouping to get a little bit stronger and understanding where we are with this. So hopefully that video was helpful to you as well. And remember, reach out to the JMED team by getting into JMED ETF. If you get into the JMED team, you just need to get into the JMED, that ETF. You know, I'll just put that on the screen. JMED ETF at Gmail. All right. And once you send an email, you'll get some information from us regarding, you know, what to do. There's the email, and then from that email, you'll be able to get connected to the math group or get some help. All right. Thank you for listening, and I hope that that was useful. That was factorizing quadratic expressions, and hopefully that helps. Bye bye. Have a great. And please remember to subscribe if it's your first time, so that people can, you know, you can build a channel and grow the channel. Thank you very much.